All right, so good evening and welcome to Master Talker online class. Please, if today is your first day of watching our video, please click the subscribe button. Okay, now we are still talking about organic chemistry. Now we are in saturated and unsaturated compound. Okay, you should know that saturated organic compound are compound joined together by just single covalent bond. What do I mean? Anyone that has just single bond, single, okay, they are called the saturated organic compound. Example are would be what? The alkane. All the alkanes are saturated, okay, but the unsaturated organic compound are the compound that are bonded by what? Double or triple bond. For example, if you have C like this, or maybe triple bonds, they are unsaturated. Example of this single bond is what? Double bond is are the alkene. Why this one what? Are the alkyne. Okay, so that is that. Let's move into the main thing, and the main thing are formulas. Now, there are three types of formulas in organic chemistry. The first one is called the empirical formula. Empirical formula. The second one is the molecular formula. And the last one is the structural formula. Okay? So we'll be taking them one after the other. Let's talk about the first one, the empirical formula. Now, all right. All right. Now, but you need to note before you write it, please note that empirical formula and molecular formula are not as important as the structural formula, because the physical and the chemical properties of a compound is determined by their structural formula. It's very very important to note, okay, that the chemical property, the physical and the chemical property of the compound is determined by this man. Is determined by this man. So these two are not as important as this, though we can use these two to get this one. This one can be used to get this one. This one can be used to get this one. Okay, but the most important one is the structural formula. So let's move to the first one, the empirical formula. This formula is you can write this formula gives the simplest compound or ratio of different atoms in a molecule. In other words, empirical formula is the simplest formula of any molecule. Example, the empirical formula of water is H2O. The empirical formula of glucose or is CH2O. Okay? The empirical formula of benzene is CH. Okay? Now this means that the ratio of hydrogen to oxygen is 2:1. The ratio of carbon, hydrogen and oxygen is 1:2:1, while this one is 1:1. Okay, so empirical formula is obtained from molecular formula by dividing the molecular formula with the HCF, that is the highest common factor of the formula. So now let's move. Example, solving time, blessing time. Let us solve. The first example we are going to solve said if the molecular formula of glucose is C6H12O6, find the empirical formula. Solution. Now if you look at this, you see that the molecular formula is simply C6H12O6. Okay, now the highest common factor of all these things is what? 6. 6 is the highest common factor. So if you divide each of them by 6, you will now find out that the empirical formula will now be what? C divided by 6 1, H 12 divided by 6 2, O divided by 6 1. So this is their molecular formula. Okay, now, but this is from the first one we said. that the empirical formula is gotten from the molecular formula by what? By dividing by the highest common factor. Now, right, but if the element is given in mole, if the element is given in mole, the mole ratio of the element will be determined by dividing the element with the smallest mole. Okay, the mole ratio is gotten by dividing by the smallest what? The smallest mole. Let's take an example to this. You can write that. The example said on the analysis of a carbon, of a compound, sorry, of a compound, 0.2 mole 0.2 mole of carbon, comma, 0.6 mole of hydrogen, comma, 0.1 mole of oxygen were obtained. Okay, then the now said determine the or find the empirical formula. Solution. Now we have the carbon, we have the hydrogen, we have the oxygen, and they are given by what is the mole. For the carbon is 0.2 mole, this one is 0.6 mole, and the other one is what? 0.1 mole. So if we divide, the ratio now is to divide by the smallest mole. So the ratio becomes 0.2 divided by 0.1, 0.6 divided by is to 0.6 divided by 0.1 is to 0.1 divided by 0.1. So we now have that the ratio is 2 is to 6. We have that the ratio is what? 2 is to 6 is to 1. So we now have that what? The empirical formula is now C2H6O. Okay? So that is the empirical formula. Another question. On analysis, question number 2. On analysis, a substance gives 0.8 mole 0.8 mole of nitrogen, comma, okay, and 1.6 mole of oxygen. Find the empirical formula. Solution. So let's write down their number of moles. So we have that solution. We have two things. Nitrogen is to oxygen, and nitrogen is 0.8, while oxygen is what? 1.6. So 0.8 is lesser than 1.6. So their ratio is what? 0.8 divided by 0.8 is to 1.6 divided by 0.8. So we have 1 is to 2. Okay, so therefore the empirical formula becomes NH2, amine. Don't forget NH2. Okay, so the next one. All right, but if the substance are given in mass or percentage, they will be converted to mole before finding the empirical formula using the below formula. Okay, we should note that what? That mole is equal to what? Mass over molar mass. Or you can say as well that mole is equal to what? Percentage over what? Relative atomic mass. Relative atomic mass. Percentage over relative atomic mass. So let us solve some question on that. The first example said on analysis of a substance, comma, 40% of carbon, comma, 6.7% of hydrogen, okay, and 53.3% of oxygen, determine the empirical, find the empirical formula. Solution. Now the first thing we need to get is the number of mole. So we know that uh, the mole the mole of carbon there should be what? The 40% all over what? The relative atomic mass of carbon is what? Is 12. Don't forget. I told that mole is equal to what? Percentage all over what? The relative atomic mass. Don't forget this formula. Very important. So we're going to have 12 divided by this to give you 3.33. Okay? Do the next one. The mole of hydrogen is what? 6.7% divided by what? 1, which is what? 6.7. The mole of oxygen is what? 53.3 divided by oxygen is 16. So what do you have? You have another 3.3. Okay, this one is 3.3, 3.3, 3.3. So now we now have that their mole ratio is now what? For we have for carbon, hydrogen and oxygen as 3.3, 6.7, 3.3. So their mole ratio is simply by dividing by the smallest. That is what? 3.3 divided by 3.3 is to 6.7 divided by 3.3 is to 3.3 divided by 3.3. So what do we have? We have 1:2:1. So their empirical formula is simply CH2O. Okay? CH2O. Let us clean. So the next question said, on analysis, a substance yield 1.6 gram of carbon, comma, 0.25 gram of hydrogen, comma, and I say determine or find the empirical formula. Solution. This is very simple. The empirical formula is we know that mole is equal to what? Mass over what? Molar mass. So therefore the mole of the first one, carbon, the mole of carbon is what? 1.6 divided by carbon is 12, right? 1.6 divided by 12. See 1.6. Sorry, 1.2 gram of carbon. It's a mistake. 1.2 gram of carbon. So we have 1.2 divided by 12. So which will give me 0.1. Okay. The mole of the next one is what? Hydrogen is what? 0.25 divided by what? Hydrogen is 1, which is what? 0.25 mole. Okay. So now let's get their mole ratio. So we have carbon and the hydrogen. This one is 0.1, while the other one is 0.25. So we now have their mole ratio. Their mole ratio as what? 0.1 divided by 0.1, okay, is to 0.25 divided by 0.25. Sorry, divided by 0.1 again. So I'm having that their mole ratio is 1 is to 2.5. So now if you multiply everybody by 2, because we don't need the point, okay? Multiply to clear the decimal, we multiply everybody by 2. By the denominator, because 2.5 is simply as saying 25 over 10. 5 into 25, 5 into this is 2, that is 2 over 5. And that this is simply as saying 1 is to 2 over 5. Sorry, 5 over 2, sorry. 5 over 2. So the problem there is 2. So multiply everybody by 2. You multiply by 2, multiply by 2. So to have 2 times 1 is 2 is to 2 times this is what? 5. So their ratio is 2 is to 5. Therefore, the empirical formula is now what? C2H what? H5. C2H5 is the empirical formula. Okay? We keep moving. All right? We keep moving. The next question said 20 cm cube. 20 cm cube of a hydrocarbon produces 80 cm cube of CO2 on complete decomposition. On complete decomposition, they now said find the empirical formula. Find the empirical formula of the hydrocarbon if 120 cm cube of O2 is used during the combustion. Okay, solution. Now this is very simple. Now we know that let's start. We have that CXHX. This is a hydrocarbon. Okay, CXHX plus X plus Y over 4 of O2 to give XCO2 plus Y over 2 H2O. Okay, so this is the formula to use. This is the formula to use for the combustion. And here I have that this one is a 20 cm. Why this one is 120 cm cube of oxygen. Okay, is using what? 80 cm cube of carbon dioxide. So if we now divide everybody by the lowest, if we divide everybody by the lowest, we are going to see that the lowest here is 20. So let's divide by 20. Divide by the lowest, which is what? 20 cm cube divided by 20. Here I have 120 divided by 20, and here I have what? 80 divided by what? 20. So what do we have now? So we are having what do we have? This into this is giving me is to 1 is to 6 is to 4. 1 is to 6 is to 4. So what does it mean? That the coefficient here is 1, everything here is 6, why this one is 4. So this thing shows that x is equal to 4, and what, x plus y over 4 is equal to what, 6. So to get our y, we have that what, 4 plus y over 4 is equal to 6. This one crossing here, y over 4 will now be 6 minus 4. So y over 4 is equal to 2. So therefore my y is equal to what, 8. If you cross multiply, you get that y is equal to 8. So if y is equal to 8, we have that the ratio of x to y is now 4 is to 8. If you break it down, you're going to have 4 divided 1 is to 2. Okay, so that is the ratio, 1 is to 2. So the empirical formula of the hydrocarbon is C1H2. So the empirical formula of the hydrocarbon. So therefore, the empirical formula of the hydrocarbon is what? CH2. So that is the empirical formula of the hydrocarbon. So combustion equation. So this thing is combustion equation. You just need to know it. That the combustion equation is what? Is CXHX plus x plus y over 4 of oxygen, then gives x of carbon dioxide and half y of oxygen or water, sorry. So that is for combustion, right? So let's forge ahead. More questions from empirical formula. All right. So the next question said, they say, what is the empirical formula? Example. Or do I get the molecular formula and then, okay, let's talk about molecular formula. We have solved questions on empirical formula. So number 2 is now molecular. Okay. All right. Molecular formula. This formula gives the chemical composition and the exact number of atoms in the molecule. It gives what? The chemical composition and the exact number of what? Atoms in the molecule. So example, they said a molecule of, okay, they said that a molecule of glucose contain 6 carbon, 12 hydrogen and 6 oxygen. Okay. The molecular formula for glucose is C6H12O6. Okay, while the empirical formula is simply CH2. Don't forget, we got that the empirical formula of glucose is H2O. Okay, but the molecular formula will tell you the exact number. This one was divided to the least. This one is the simplest, but the molecular formula will tell you the exactly that is there. And the exact that is there is what? 6 carbon, that is C6, 12 hydrogen, H12, and 6 oxygen. Okay, that is the molecular formula for glucose. So also the molecular formula for ethanoic acid is C2H4O2, but why the empirical formula is C2HO. So you see that empirical formula sometimes will confuse you. You may not even know the exact formula or the exact compound they are talking. Ethanoic acid. The empirical formula is still the same, CH2O, but the molecular formula will tell you the actual carbon, actual atoms that are there. So this one is C2H4O2. Okay, so that is ethanoic acid, and so on and so forth. Okay, so therefore, mathematically, to get the molecular formula is simply N times the empirical formula. N times the empirical formula. Okay, so let's solve. Example, we have that the empirical formula of Huh? Okay, galactose. The empirical formula of galactose, okay, is C CH2O. CH2O. Okay. Then I say determine the molecular formula if N is equal to 6. So solution, we know that a molecular formula is simply N times what? The empirical formula. So what do we have? 6 times the empirical formula is CH2O. So 6 times the carbon will give you C6. 6 times hydrogen will give you H12. Then we have the O6. So this is the molecular formula of that compound. Example, example number 2. I think I'll stop in the molecular formula. Then in the next video, we'll talk about the structural formula. Example 2 said the empirical formula, the empirical formula of a substance is NO2. Find the molecular formula if N is equal to 1. Solution, we have that the molecular formula is simply N times the empirical formula, which is what? 1 times what? NO2, which is what? The same NO2. Okay? So right, this one is a situation where N is given. So right for me. But if N is not given, replace the molecular formula with molar mass. Okay? Replace the molecular formula with molar mass. Therefore, molecular formula is equal to what? Uh, sorry, we have to know that what? Molar mass is equal to what? N times empirical formula. That's for me to get my N. Okay? So the molar mass is given by that N times the empirical formula. So let's solve an example to show, to illustrate this thing we just said. So we have that the empirical formula of a substance is NO2. Okay? Determine the molecular formula of the substance of 92 gram per mole. Okay, so let's go. So what do we have now? Solution, we have that. Don't forget that what? The molar mass is simply what? N times empirical formula. So what do we have? We now have that what? The molar mass here is what? They gave us the molar mass as 92 gram per mole. So 92 is equal to what? N times the empirical formula is given as what? NO2. So which is what? 92 is equal to what? N times, this is what? 14 plus what? 2 into 16. Don't forget. So what do we have? We now have that what? That 92 is equal to what? N times 14 plus 32. 14 plus 32. So what do we have? 92 is equal to what? 46. 46n. 46 times this, 46n. So my n is now what? 92 over what? 46. Which will give you what? Which will give you 2. I've gotten my n. Therefore, the molecular formula is what? N times what? The empirical formula. Which is what? 2 times what? NO2. Which is what? N2O4. That is the molecular formula. N2O4. So another example, they said if the empirical formula of of the hydrocarbon is C5H11. Find the molecular formula of the hydrocarbon if the molecular mass is 142 gram per mole. Solution. Okay, don't forget that that empirical formula, that molecular mass is equal to what? N times what? Empirical formula. So the molecular mass they gave me is 142 is equal to what? N times the empirical formula there is C5H11. So what do we have? 142 is equal to what? N times 5 of C is 12, don't forget, plus 11 of 1. H is 1. Don't forget. So I have 142 is equal to what? N times 12 times this is 60 plus 11. So we have 72. So what do we have now? We now have that 142 is equal to what? 72n. So n is 142 divided by 72. So what do we have? We have 2. Is it 142 or 141? Sorry, 141. I'm sorry, 71. Sorry, not 72. So we have 2. Okay, so don't forget that our molecular formula is still n times the empirical formula. So which is what? 2 times C5H11, which will give you what? C10H22. So that is the molecular formula. Okay, we forge ahead. So the next one said the percentage of Fe in an oxide is 70%. Find the molecular formula of the oxide if the molar mass of the oxide is 160 gram per mole. Okay, now very simple. Solution. We have that the percentage. Okay, first of all, the percentage of Fe they gave me as what? 70%. And this is an oxide. That is, oxygen is involved. Okay, so which means the remaining percentage is now for oxygen. So the percentage of oxygen will now be 100% minus the 70%, which will give you what? 30%. Okay, so let's get the mole. The mole of Fe is simply the percentage of Fe all over what? The relative molecular mass of Fe, which will give you what? 70 divided by 56. Don't forget that Fe is 56, which will give you 1.25. Okay, let's do the same thing for oxygen. The mole of oxygen is now what? The mole of oxygen is percentage of oxygen divided by what? The molar mass. So which is what? 30 divided by 16, which will give you 1.8. Okay, so what do we have now? 1.88. So we now have that the mole ratio is now what? Fe and oxygen. This one is a 1.25, 1.88. So the ratio will now be what? 1.25, the smaller one, divided by 1.25, and 1.88 divided by 1.25. So what do we have? We now have that the ratio is 1 is to 1.5. 1 is to 1.5. So we don't need the point. The point 0.5 means it's being divided by 2. So if you multiply by 2, multiply by 2 to have 2 times 1, 2 dot 1.5 divided times 2 will give you 3. So 2 is to 3. So this will now help us to get the empirical formula. The empirical formula is now equal to what? That is Fe2O3. Fe2O3. That is the empirical formula. So to get the molecular formula, can I clean here? Yeah. To get the molecular formula, I know that molar mass is same thing as what? N times the empirical formula. So don't forget this very important formula. So I have 160 is equal to what? N times the empirical formula is Fe2O3. So I have what? N times 2 into Fe is 56, right? Plus 3 into oxygen is 16. So if you close, you will now have that 160. So you will now have that what? 160 is equal to 160 is equal to what? N times 2 times 56. 2 times 56 will give you 112, plus the other one will give you 160. So 112 plus 48. So what do I have? 160 is equal to what? 160n. So my n is now 160 divided by 160, which is equal to 1. So therefore, my molecular formula is equal to what? Empirical formula times n, which is what? Molecular formula is simply what? Empirical formula is Fe2O3 times 1, which is what? Fe2O3. As simple as that. So that is the molecular formula. Right? So I think we're going to solve just 3 more questions. Let me check my time. Okay. Let's solve just 3 more questions and then we are good to go. 3 more questions. So they said on analysis of a substance, on analysis of a substance, 40%. I think I've done this before. Okay, I've done this particular question before. So, okay, let's take another question. They said when 1.7 gram, okay, 1.4 gram of a hydrocarbon was analyzed comma, it gives 1.2 gram of carbon, 1.2 gram of carbon and 0.2 gram of hydrogen. Okay, then I say find the molecular formula. Okay, if its molecular mass is 56 gram per mole. Solution. Right. So all right. So solution. We know that mole is equal to what? Mass over what? The molar mass. Okay. For the carbon, The mole of carbon is, what is the mass of carbon? They say 1.2 gram of carbon. So 1.2 divided by 12, which will give you what? 1.2 divided by 12 will give you 0.1. Okay, 0.1. Then of the mole of hydrogen, because the hydrocarbon. So mole of hydrogen is now what? 0.2 divided by 1, which is 0.2. So the ratio for carbon to hydrogen, the mole ratio, carbon is to hydrogen is what? 0.1 and 0.2. So if you divide, you now have divided by 0.1 divided by 0.1 to have 1 is to 2. Okay, so 1 is, therefore the empirical formula is now CH2, C1H2. So we know, to get the molecular formula, we know first of all that molar mass is equal to what? N times empirical formula. Don't forget. So and the molar mass is what? 56 is equal to what? N times CH2. So 56 is equal to what? N times 12 plus 2 into 1. So which is what? 56 is equal to what? 14n. So n is now 56 divided by 14. And 56 divided by 14 will give you what? 4. So we have gotten our n. So therefore, the molecular formula is simply n times the empirical formula. So which is what? 4 times the empirical formula is what? CH2. So the answer is now what? C4H what? 8. So I'm going to stop here. Thank you very much for watching. Please don't forget to like, share, subscribe, and comment. Bye bye.